All right, we're back again. This is still Pre-Calculus 12 with Mr. Abbott, and we are still on Learning Guide 2, and it's part 3 now, the final piece of Learning Guide 2. All right, so we are going to be looking at topic 4 now, and this is inverse of a relation. And just remember, inverse is one of the 3 types of reflections. There's a reflection on the x-axis, there's a reflection on the y-axis, and there's an inverse reflection, which is a reflection on y equals x. Okay? So we can do it visually, and I'll just quickly show you, but I'll show you an easier way. Because remember, this is a reflection on this guy, so if I drew y equals x, it's basically a line that's doing this. So you're basically taking this piece right here and flipping it over. Okay, so it's kind of difficult to do it by just visually. I always recommend that you take the points of the relation. So here's all these points. So I took that point, that point, that point, that point, and that point. And what I've done when I do the inverse is the x becomes the y and the y becomes the x. So you basically just flip them around. So here is all my new points. See how they flipped? It used to be -7, 2, -2. Now it's -2, -7. So then I can plot all these, and voila, there is the answer. Okay, to do the domain and the range, okay, we just have to get the parameters. Well, if we look at the original function, so the domain here is going from there all the way to there. So that's the domain. So that's how I got -7 and 4. And if I'm doing the range of that, remember the range is the highest and lowest. So there's the lowest point and there's the highest point right about there. And so I know that's going from -3 to 5. Okay? Now, if I'm doing the inverse relation, again, I take the furthest left to the furthest right, and there it is. And I take the highest and lowest, and there it is. But you'll notice something, that if you have these guys, they just flip around. Like the domain becomes the range of the inverse, and the range becomes the domain. So they just sort of switch around. Okay, is the inverse a function? Well, if you look at this red one, if I draw a vertical line right there, it doesn't matter where, there, it touches in more than 2 places, so the answer is no, or it's not a function, because it doesn't pass the vertical line test. Or if you didn't want to draw a picture, you could take the original, this guy right here, this original, and do the horizontal line test. So it touches there and there, so it's no. So to save you time and effort, if it just asked you, is the inverse a function or not, just do the horizontal of the original, the horizontal line test of the original, and that's quick and done. Okay, so let's try this one. Okay, so first of all, I want to get the base function. So it's this guy right here. So I need another little bracket here just to get some points so I can do some mapping. So remember, we're dealing with that. So it's 0 and it's 0, it's 1 and it's 1, it's -1, it's 1, it's 2 and it's 4, it's -2 and it's 4. So now the mapping of this guy, x is just x, I'm just adding 1 to the y's. So let's write all these in. X is not changing. I'm adding 1 to all these guys. Now when I do the inverse, and this is the little notation for inverse, this is sort of -1 business. Okay, I just switch these around. So 1, 0, 2, 1, 2, -1, 5, 2, 5, -2, and then I can sketch. So 1, 0, 2, 1, 2, -1. 5, 2, so 1, 2, 3, 4, 5, 1, 2, and then 5, -2, and it's doing sort of a sideways parabola. Okay. Now, sometimes when you get functions, you can put a restriction on the domain so you can make the inverse a function. So here's an example. So that last one I gave you, if I sketched this, if I sketched this guy, it was looking like that, and then the other side would come up, right? And remember that picture I just sketched, it gave us that U shape, right? Well, I know that the inverse does not pass the vertical line test, because if I draw a vertical line here, it's touching in two places. So what I want to do is just quickly restrict the domain. So I just take this half off, and what happens is when I inverse it, I only get this piece here. I don't get the bottom piece. So therefore, it has passed the test. So what you need to do is quickly take the domain, and it's quite easy, that because you have this function, if I just take off 1/2 of it, so if I say that x has got to be greater or equal to 0, so that's the domain, it's taking all these points right here. It's leaving out all the negative side. Say I only get this blue piece. So if I reciprocate it down, I have the answer. Okay, now we're going to work with finding inverse equations. Okay, so here's the first example. So it wants the inverse. So these are the steps we're going to follow. The first thing is we replace the f of x with y, because f of x is y. Second, we want to interchange. Where we see a y, it becomes an x, and where we see an x, it becomes a y. And the third step is we're just going to do some algebra now to isolate y. So I subtracted 2, I divided it by 3, and then I rewrote it with this notation. Okay, that's our symbol for inverse. So make sure you write that, and there's the answer. Okay, let's try this one. So you can pause, have a go, and then look at mine. And there is the answer. Okay, remember to put that notation. This is your inverse notation. All right, and okay, let's look at another example. Getting a little harder. Okay, so this one here, I'll go through step by step. Okay, so let's change to y. Now we're going to interchange x's with y's and y's with x's. Now this one is a little harder because it's got two y's. So see, there's a y here and there's a y there. So we're going to have to do a couple steps. So let's times this side by y plus 3 to get rid of that. So we have to times this side by y plus 3. So we get xy plus 3x. Okay, so this is where we have to gather up the y's. So I'm going to bring this y to join that y, and this one doesn't have a y, so it's going that way. So I'm collecting the y's to one side. Now you notice that there's two y's, so we're going to factor out a y, because we want one y. Okay, so see how I went from two y's to that one y, just by factoring. Okay, now I can divide out. And I have my y isolated. And remember to make it f negative 1 of x equals negative 3x over x plus 2. And there is the answer. Okay, so let's look at one more example here. So again, let's change this to a y. Interchange. Okay, so what are we going to tackle first? Just remember reverse BEDMAS. So we're going to subtract 1 from both sides. And then we're going to divide by 2. Now how do we get rid of a square? Get rid of that, we square root. Don't forget the plus and minus, really, really important. Now I got to bring that guy over because I get the y by itself. Oops, I just messed up there, I put a plus. Okay, minus 1 over 2. And we bring that over and add 4. And just change this guy to its proper notation, and we're done. Now if I wanted to restrict this domain, so the inverse is a function, you look back at the original, remember the domain is the x, and you can say it's everything greater than the opposite of negative 4 is 4. Or you can say everything less than. Doesn't matter.